Here we will show you how to flash the new Sonoff RGBC W Smart Bulb that is using the BL602 Wi-Fi module, so we can free it from the cloud and pair with Home Assistant. Our method will also apply to other IoT devices that are using BL602 platform, for example to the new Sonoff Power Metering Smart Relay and the Magic Home LED strips. Okay, here is the bulb. Note the marking. You can check if your bulb is similar. Let's start with removing the dome. It should be very easy to do. Now you can see a board with LEDs. There are separate cool white, warm white, red, green and blue LEDs. There is also I2C LED controller called BP5758. This bulb is not using PWMs, but don't worry, OpenBeacon firmware already supports it. Remove the bottom pin. It can be simply pried. It is removable and can be put in its place back later on. Don't lose the pin once it's removed. Now remove the thread. We have used a wrench for that, but you have to be careful. Do not squeeze or damage the thread too much. Thread is also removable. Now you can see both wires coming out of the bulb. One of them is a fusible resistor lead. It's time to remove the board with LEDs. Remove the glue from around the board. Carefully pry the board, do not damage the LEDs. In this case, the whole module from the bulb came off. Now you can easily remove the board with LEDs. As you can see, there is no ESP chip inside. The module here is using BL602. The boot pin marking can be a good indicator of BL602 chip inside. Okay, we will have to solder 5 wires. Power supply, which is 3.3 volts, UART lines RX and TX, and a boot signal. Schematic is shown on the screen. Power supply can be soldered to the pins of the capacitor. You can clearly see that they are connected directly to the Wi-Fi module. First add some flags to the pads, then add some PB solder. Next tin the wires, then finally solder the wires. Do not move wire away from the board too early, wait for solder to solidify. Soldering UART lines is a bit harder in this case. You have to solder directly to the Wi-Fi module pads, still it can be done with some patience. Again, flags, solder, wire. Now the last solder joint, boot signal connection. Just like before, first flags, then tin the pad, then solder a wire. Now connect everything according to the schematic. Next, download the proper firmware binary from GitHub, the BL602 build, and use the BLDevCube to flash it. You need to change only one setting in BLDevCube, the firmware bin path. Just point it to the binary file that you have downloaded from GitHub. All other settings can be left default as you can see on the screen. This is not a BK7231 chip, so you don't need to do anything else, no power cycle is required. Just press Create and Download button and wait for flashing to finish. Next, in order to check if everything is connected, disconnect the boot signal and do power off and power on cycle. The open BL602 access point should appear. Open BL602 configuration web page and start with configuring your Wi-Fi SSID and password. The device will reboot and connect to your Wi-Fi. You can also already configure MQTT first in the MQTT tab. You can find a new IP of your device on your router DHCP clients page. Open the BL602 page again. This time you can use it to configure your device I/O. This particular bulb is using LED driver and requires only two signals to control RGB CW controls. See the device configuration on the screen. If you have some other device and need to figure out the configuration, you can always check our forum. We have our teardowns and template list with many devices, and even if your device is not listed, we can help you with reverse engineering it. Remember to restart the device after configuration changes. The LED controllers should appear on the screen after reboot. Once you know that OpenBL602 is working well, it's time to desolder the wires. Always desolder wires first, do not connect the device to mains before that. Finally, we can connect the bulb to mains and see if it works. As you can see, LED driver works. We can easily change colors of OpenBL web panel. Put the board back inside the bulb case. First, put on the thread. Make sure that wires are connected properly. Then, connect the bulb pin tip. Finally, put on the dome and glue it if it is needed. Now it's time for final test, but first one more thing to note. The order of color channel may be different between devices. If you have swapped colors, for example, the LED is showing green color when you select red, you need to change the map of the colors with a map command. List of map commands is available on the screen. Map command takes 5 arguments, which are color indexes, so you can set any color order. Since the latest update, the map command configuration is saved automatically and remembered after reboot. No restart is needed after this command. You can just change color again to see the results. Okay, let's check if the bulb works. As you can see, both RGB and temperature modes are working. Dimmer control is also working. Now you can pair the bulb with Home Assistant, but we already have a video about that. See our channel for more information. You can also visit our forum and device teardowns and templates list where you can find details and flashing guides for many other products. You can also submit your own teardown or IoT device review to help us and get a free gift from Electroda. More details in the video description. See you on the forum.